Good afternoon, everybody. It's Tuesday, November 20th. We are going to finish up section 5.3 today. Solving some exponential equations. There we go. All right, here's the first one. 5 to the x equals 5 to the negative 6. All right, well, 5 to the something equals 5 to the negative 6. Clearly, x has to equal negative 6. This one, not so nice, unless we realize that that 81 can be rewritten as a power of 3, and we can rewrite this as 3 to the negative x equals, well, 81 is 3 to the 4th. Now we have the same base, so that says negative x equals 4. Oops. I'll write that out in a moment here. And x is equal to negative 4. All right, that's better. Look at this one. 5 to the x plus 3 equals 1/5. You're going to have to change this right side to have it be a power of 5. 5 to the x plus 3. Okay, what power of 5 is 1/5? That is 5 to the negative 1. So x plus 3 then has to equal negative 1. And when we solve this, we will get x is negative 4. Right? How about this one down here? 9 to the negative x plus 15 equals 27 to the x. Do not have the same base right now. We need to change them to be the same base. 9 and 27 are both powers of 3, so we could rewrite this 9 as 3 squared to the negative x plus 15. And this 27 we could rewrite as 3 cubed to the x. And now I need you to remember, when we raise powers to a power, we multiply the exponents. So this is 3 to the negative 2x plus 30. And on the right side, again, powers raised to a power, we multiply the exponents, leave the base the same. So that's 3 to the 3x. Now, 3 to this piece has to be 3 to that piece. Those two have to be equal. So negative 2x plus 30 equals a 3x. Solving this, let's add that 2x over. And x is 6. Next one here. 5 to the x squared plus 8 equals 125 to the 2x. Get the same base. And base 5. And 125 is 5 to the 3rd to the 2x. On the right side, powers to a power, we'll multiply those, so that's 5 to the 6x, which says now that x squared plus 8 equals 6x. Well, we're quadratic now, so let's move that 6x over. X squared minus 6x plus 8 is 0. Oh, factor x minus 4 times an x minus 2. It'll give us two solutions here. X is 4 or x is 2. Okay. How about this side over here? Oh boy. Ooh, all base 3. Let's change those. So this is 3 squared to the 2x times 3 cubed to the x squared equals 3 to the negative 1. Powers to a power. There's 3 to the 4x times 3 to the 3x squared equals 3 to the negative 1. All right, now this gets tricky down here. I need you to come off to the side and think about this from ages ago in the past. If I give you something like this, x cubed times, let me scooch this over to make sure you can see it, x to the 4th, so we're multiplying things, we add the exponents, that's x to the 7th. What does that mean for us down here? That means that we're multiplying things with exponents, so we add the exponents. 3 to the 4x plus 3x squared equals 3 to the negative 1. Oh, perfect. Now we can say that the exponents are equal. So 4x plus 3x squared equals a negative 1. Quadratic again, let's pull this 1 over. So we have 3x squared plus a 4x plus a 1 is 0. Factor. So it has to be a 3x and an x, and the only option's a 1. Let's check it. Out it's 3x squared, then there's a 3x and a 1x, there's 4x, and 1 times 1 is 1, so we are correct. And x is negative 1/3, or x is the negative 1. Whew! Alright, let's try this one down here. Okay, now don't get freaked out because of the e's in there. Remember, e is just a number. It's a number. It's an ugly number, but it's a number. So let's write this. A couple of things I can do. Gotta leave that as e to the x squared. E to the 3x times, now rewrite that. That's e to the negative 2nd. Now we're just like the last problem. We're multiplying things with exponents. So we leave the base the same, add the exponents. And then we have the exponents, x squared equals 3x minus 2. Pull this 3x over and that 2. Factor. Uh-oh. What did I do wrong? Oh, you got it. It should be minus. X equals 2 or x equals 1. Okay, these three problems all had quadratic in it and they all factored. What would you do if I ended up with something that didn't factor here? So if the quadratic equation doesn't factor, then what? Yes, use quadratic formula, which you all have memorized. All right, now the best part, word problems on the next pages. I know you are so excited to do these word problems. I know it. All right, here we go. Here's the first one. The atmospheric pressure P on a balloon or plane decreases with height. The pressure measured in millimeters of mercury is related to height in kilometers above sea level by the function P of H is 760 e to the negative 0.145 h. Find the atmospheric pressure at a height of 2 kilometers. So this h, height, and P, pressure. This is all calculator here, guys. So go ahead and grab your calculator. And this is just an exercise in typing this in. So we want the pressure evaluated at 2 kilometers is 760 e to the negative 0.145 times h, which is 2. All right, here we go. So straight off the home screen, 760 e. Now remember, there's 2 places to find e. Since I'm raising this to an exponent, I'm going to use this one down here. Oops, this one down here on the ln. So second ln. It pulls up the exponent, and then let's just go negative 0.145 times h, which is 2. Let your calculator do the work for you. Enter. Uh-oh. Oh, did I do a minus sign instead of negative? I did. I put a oh, I'm glad I did that actually, because that's happened to you, I'm sure, sometimes. Can't use the minus sign on this calculator. You have to use a little negative sign when you have a negative number. There we go. 568.680. 568.680 millimeters mercury. Oh, a little cross-curricular learning with that mercury symbol there. Okay. All right, what is it at a height of 10 kilometers? So just arrow back up and pull that down, or if you have one of the older calculators, you just do second enter, and that will repeat the previous line as well. And then we're going to go back in, and I'm just going to change this 2 to a 10, and there we go. So P of 10 is 760 e to the negative 0.145 times 10, and that is 178.273 millimeters mercury. Okay, just a little cloud over here to get you to think how big is 2 kilometers. So we're talking about a balloon or a plane going up in the air. How high in the air is 2 kilometers? 10 kilometers. Most of you don't think distances that way. Most of you think miles. Who's the cross-country people in here? A 10K race is about 6.2 miles. So 6.2 miles up in the air. That's greater than 30,000 feet. It's an altitude of 30,000 feet. That's about what planes fly when they're going cross country. So greater than 30,000 feet. Okay, so 2 kilometers, 1/5 of that. So just do 6.2 divided by 5, so 1.24. So 2 kilometers is 1.25 miles high. 1.24 miles. Okay, just to give you a rough idea of how tall in the air we're letting this balloon fly and this airplane fly, and it talks about the pressure on that balloon. All right, look at this next one. Between 5 and 6 p.m., cars arrive at Jiffy Lube at a rate of 9 cars per hour, 0.15 cars per minute. The following formula from probability can be used to determine the probability that a car will arrive within t minutes of 5 p.m. So f of t equals 1 minus e to the 0.15 t. So that f is your probability. T is time in minutes. Okay, determine the probability that a car will arrive within 15 minutes of 5 p.m., which is before 5:15. So the probability of 15 minutes is 1 minus e to the negative 0.15 times t, which is 15. Okay, so all calculator again. Can you see this okay? Oh, I better move it over here, huh? Oh, I don't know. I'm going to have to leave it there, maybe. Minus e to the negative 0.15 times 15. 0.894. So 89.4% chance. Uh-oh. 99% chance that a car will get there within 15 minutes of 5 o'clock. Determine the probability that a car will arrive within 30 minutes. So plug in a 30. I'm just going to arrow back up, grab this, change that 15 to a 30, and 98.8% chance. Oops, 0.988. I'm rushing here, guys, trying to get this done before the bell rings in 8 minutes here. Okay, what value does f approach as t becomes unbounded in a positive direction? So f of t is 1 minus e to the negative 0.15 t. All right, t becomes unbounded in a positive direction means that t is going to infinity, a huge positive number. So then we're taking e to a negative huge number, and e to a negative huge number goes to 0. And e to a negative huge number, well, that's 1 over e to a huge number. That's going to 0. So all this piece here goes to 0, which means that probability approaches 1. That probability approaches 1. Okay, now graph this function using your calculator. So let's put this in here. Y equals 1 minus e to the negative 0.15 t. I had to use x there, I don't have t's. Okay, zoom 6. Oh my, we need to change this a bit. The maximum y value here is a percentage, so, well, it's not percentage, it's a probability, so it's got to be less than 1. So I'm going to change my window here. X's, I'm going to drop that -3 to, let's let this go for 60 minutes, so within an hour. And y's, let's go -1 to, say, 2. There we go. Here's my window again if you missed it. I want you to sketch this graph onto paper. Gotta move it. Looks like this. And there is a horizontal asymptote here at y equals 1. Okay, next part. How many minutes are needed for the probability to reach 60%? So f of t, I'm just writing the equation again, 1 minus e to the negative 0.15 t. This time I didn't give you the time value, I want you to find that. I gave you the probability. So a 60%, 0.6 equals 1 minus e to the negative 0.15 t. Right now you do not know how to solve this algebraically. You are going to have to do this on your calculator. To do this, put that in y2. You already have this in y1, and then look for an intersection. So I'll do that with you. y1 is already there. y2, I'm going to put in 0.6. Graph. Intersect. So second, calc. Intersect. It asks me for the first curve, which is y1, so I hit enter to say yes. It asks me for my second curve, which is identified as y2, so I hit enter to say yes. And it asks me for a guess. So I'm just going to arrow closer to that intersection point. And the intersection is right there, 6.108. So T is 6.108 minutes. Okay. Notice my answer is not an ordered pair. There's only a T in the equation. So when I give my answer, I'm just giving the T value, in this case X, because that's what I used for T, not the ordered pair. Okay? Let's see if we can get this one done quickly. People enter a line for a Demon roller coaster at the rate of 4 per minute. The following formula from probability can be used to determine the probability that X people will arrive within the next minute. P of X is 4 to the X, e to the negative 4. Ooh, factorial. We need to talk about this. Factorial, let me show you like a 5 factorial. That means 5 times 4 times 3 times 2 times 1. So this probability, P of 5, is 4 to the 5th times e to the negative 4th. That's always a 4 there. All over a 5 factorial. Okay, let me show you where these buttons are on your calculator. So let's quit and get out of here. Clear that screen. So I want a fraction, alpha F1, 4 to the 5th, e, so I'm going to use that ln so I can get a negative 4 here, all over 5. All right, factorial. Factorial you can find is go to math right here, arrow over to probability, which is PRB, and there it is, the 4th one down. Okay, enter. 0.1562. 0.156. Oh, there's the bell. I'll write this one out real quick. P of 8, it's the same idea. It's going to be 4 to the 8th times e to the negative 4th, all over 8 factorial. Let's arrow back up. Grab it. Okay, now what changes? That exponent changes to an 8. This 5 factorial turns to an 8 factorial. And 0.029. Okay, whew, I think that's it. Seth? I think that's it. If I went too fast, feel free to rewind this at your leisure and pick up what you need. Thank you very much. Have a nice day. Bye.